Happy Monday.
Happy Monday. How's it going, Joe?
Good, good. So for the audience out there, we're doing the Monday morning data chat live today because it's Monday, so why not? So, you there?
Yep.
Okay.
You hear me?
Awesome. Yeah, I can hear you just fine. Yeah,
Okay,
sorry.
good. Okay.
Glitch here, awkward. Cool. So anyway, I think some things we wanted to talk about. We're going to be doing a live Q&A, so as people start joining in, feel free to ask questions. That's what we're here for. But I guess to kick it off, any topics in data engineering that you want to talk about?
Yeah, I mean, you sent me that interesting article about Dagster last night, and I was kind of an early adopter of Airflow. I still love training teams on Airflow, but yeah, that article was pretty compelling about the reasons why it's time for next generation technology. What was your take on it?
I think what's I'm always stoked to see new things come about. I don't have as much Airflow experience as you do, so I mean, but I'm curious about what stands out to you, if anything does.
So it's this whole discussion that I think by now we've been having for even several months about the tooling around data, right? Just improving dramatically, and data engineers have a larger domain of responsibility in terms of data management. Organizational data management is something we've talked about. And so one thing I was seeing from this article, let's see if can we post this link somewhere so people can actually see it on the discussion?
Yeah, I'll post it. Yeah.
Okay, awesome. Anyway, one thing that stood out to me is this sort of shift in focus, enhancing Airflow with like more data ops type features, making deployments easier, but also adding data cataloging features. It sounds like Dagster's not trying to be the end-all be-all data catalog, but they want to have enough of a data catalog that you can go find your data and figure out why it's broken. So if I'm like an analyst, like, hey, this data is messed up, I can actually go into the Dagster interface, go look for my data and see, oh, my task didn't run or something's wrong. And then I can find the responsible data engineer and email them or something like this. And I mean, Airflow has come a long ways from the early days. At the same time, I think the author of this article points out that some early architecture decisions were made that are going to be hard to overcome in the long term in terms of enhancing it with more high-level data management features and data ops features.
Right. Yeah, I think that makes sense. Well,
yeah.
I mean, welcome to the modern era of data tooling, where
I know
everything changes. So,
yeah.
I mean, I was writing about this today. I think it's, I was writing about just data ops and how it relates to data engineering, and I find it's, orchestration definitely has a role in data ops. Although I think it also straddles probably other areas as well, because orchestration is not typically an area of DevOps, for example. So, I'm not sure what you think about that.
Yeah, I mean, I would say so orchestration is kind of data ops. It's also, in some sense, part of almost the application layer of data engineering. So where with applications, you would have services and APIs and things to manage, data flows within the application, not for analytics so much, but more for making the application actually work. And orchestration kind of does the same thing. It's what manages the data moving around, but in batch instead, where batch is the appropriate paradigm. Yeah.
Yeah. What about streaming?
So one thought I've had about streaming is that one of the key challenges in the future is going to be better tooling for just managing all your streams, right? How can you create a more fluid environment where it's much less friction to divert a stream or to fork a stream or to add these kinds of capabilities, right? It's certainly possible to do all of that right now, but I think there's still some friction involved in creating new streams and new targets. Now, I'm not an expert in Pulsar by any means, but people have been telling me that Pulsar is doing a lot of these things where it's very easy to, fork a stream and then add some transformation layer on top of it and create a new target for it, that kind of thing. So,
Yeah. I mean, the big question I keep getting asked too is about data modeling streams. Like, how does this reconcile against, your traditional batch data modeling, in particular, Kimball, for example, right? I think that's still, I have not seen much in this area. I guess if the audience has any interesting articles or materials on this, definitely drop it in the chat here. I personally haven't seen much in this area. I think it's something I'm going to be writing about and talking about a lot more, especially, given the stat that 30+% of data is going to be streaming in 4 years. So
totally makes sense.
I mean, and I think that number is only going to keep growing. So, need to model data, need to orchestrate streaming data is just only going to keep going.
Yeah.
Let me see. I got a question here. Raymond Tan, can you help go through batch moving of data, say from SQL Server, Excel sheets to data warehouse and data lakes?
Yeah. Yeah, we can talk about a couple of different paradigms for that.
What comes to mind?
Okay, so actually this was something I was writing about recently. So when you're talking about this type, when you're pulling in particular from like a SQL Server, so an operational database, there are a couple of main paradigms that we tend to talk about. Make sure I follow. Yeah. Okay. So one paradigm, and this is very traditional data warehousing, is the batch snapshot approach. And that is once a day, I just take a snapshot of the current state of, say, my SQL Server, and then that gets moved over into some kind of ETL tool. I have snapshots from a bunch of different tables, and then I have downstream transformations that happen. Another paradigm would be CDC, and I'll let you talk a bit about CDC.
Yeah, CDC, not the Center for Disease Control.
Right.
It's change data capture. So there's a few ways you can do this with SQL Server, for example. I mean, you could just set up a listener on, changes to SQL Server tables. SQL Server also has a notion of temporal tables, so you could, just track changes in those. But regardless, you're gonna capture changes. So these are create, read, update, delete operations on your data in your table, and then transmit those into probably a landing zone in your data warehouse. From there, you can transform the data, however you want, whether you're going to have it downstream in a dimensional model or just some sort of ad hoc table or data mart or whatever you want to do. So, it also mentions Excel sheets. I mean, there's a number of tools that will just take Excel sheets and then load those in, as needed. I mean, typically what we see is just people load them in on a frequency. So I'm not aware of any tools that capture deltas from Excel sheets and then load those into data warehouses. Are you?
I'm not. I was going to mention, I mean, on the Google side, they have something kind of cool where you can point BigQuery, which is their main data warehouse, at Google Sheets and basically just query directly from the Google Sheet. And so you can use that as part of your ETL flow. But like, I don't think there's any direct support for Excel sheets unless you import them into Google Sheets somehow. And so I'd be curious, I actually don't know the answer to this, if there's something similar with Office 365 and Excel and then Azure.
Oh, I would think that they're going to be working on that. If they don't, that's that's a pretty cool feature, actually.
Yeah.
So Raymond also asked, thanks. So you do these CDC and ETL?
Yeah, that's a good question. I mean, it's interesting because I would say, and tell me if I'm wrong here, but I think often CDC is used within a traditional batch ETL pattern where you have the CDC coming out, but then you only really post-process it once a day. But then the newer paradigm is to take that CDC and send it into something like Kafka or Pulsar, where you can do real-time processing on top of it.
Yeah, but I would say that the CDC is the E and the ETL part, right? So yeah. Let me see. There's a couple of comments on the CDC part. There is true CDC release features that we're pushed, including backwards to SQL Server versions of old. You understand what he's trying to say here? I think
at least part of it. Maybe I'm getting that we're almost doing some reverse ETL here.
I don't know. Darren, if you want to clarify that would be great. Sanjeev also says, in data warehouse for CDC's source sends us delta, and we develop the code to do slowly change the dimension at code level. That's absolutely right.
Yeah.
Yep. So, because your CDC contains information about what's a new row, what's an updated row, timestamps and all that. It makes slowly changing dimensions pretty easy to do.
Yeah.
So some other paradigms that we see too was just, maybe using analytical functions, just take them, rank the same IDs, take the most recent, that kind of stuff. So there's a number of ways that you can identify the information you want to use and use it. So got a question. I don't know if it's a question or a statement. In a traditional world, to meet business BI requirement that we followed a dimensional modeling approach. Now adoption of data lakes, how dimensional modeling can be replicated, or is there a better way to achieve these BI requirements?
It's a good question. This is an ongoing conversation that we've been having for a while now, Joe, and I don't know that we fully have the answer. What's your opinion in this moment?
I would say it's an interesting one. I think that people will go for it's a question of performance.
Yeah.
Versus things like business logic and balances of those sorts of things. The reason I mentioned performance is say that you need to update the data in your dimensional model very quickly. You might be better off using wide or nested type of data just for performance reasons. Now that obviously comes at the cost of maybe not having a completely coherent model for your data. So, but then for data lakes, I don't really see data lakes and data warehouses as being much different in terms of utility, not these days. And then you have the lake house and whatever buzzword you want to throw in there. So, yeah, I don't know. What are your thoughts?
I think culturally, we've seen two camps on this issue. So you've got kind of the big data camp that people coming out of Google or Silicon Valley who just wanted to completely discard Kimball and any kind of dimensional modeling and ignore those traditional approaches. And on the other hand, you had people who were coming from more of a traditional data warehousing background, adopting new tools like Redshift, say, who wanted to completely impose the existing Kimball model. My opinion is that probably the correct answer is somewhere in between. I think dimensional modeling and Kimball are still really useful, but you can also relax some of the normalization requirements that you had with traditional data warehouses. To use like repeated fields and structs and other things that just weren't even allowed in, say, a Teradata system. I think for a lot of business data applications, that's the sweet spot where you take Kimball, you do some dimensional modeling, but then don't require absolute normalization and kind of denormalize a bit where it makes sense for your data. The other thing I would say is that often you have different consumers with different requirements for that data. And so for data science, the recommendation we're starting to see is do your CDC, but keep that raw CDC table somewhere. And then your business users can hit like the very normalized, nice version of the data. The data scientists may care a lot more about the event data that shows up in CDC and want to query that directly without the dimensional modeling essentially already imposed.
Yeah. Yeah, it's an interesting one. I mean, I would say, the contrarian notion of just eschewing any data modeling or dimensional modeling, right? I think this comes back to haunt people after a while.
Yeah.
So at some point you're going to have to make sense of your data. And I mean, the nightmare scenarios that we see is when people don't do this, and then it's just sort of a free for all. This happens a lot. I would say that the modern tooling actually gives you more than enough liberty to make tons of mistakes in this area. So just be aware of it. Every time I talk about this, I think they still refer back to the data warehouse toolkit as just I think it's a good reference for. Data modeling is also agile dimensional modeling or whatever the book is, and that one's awesome too. So, yeah, anyway, I hope that answers your question in a very roundabout way. So, Darren Child also said CDC was released as a solution in SQL Server, so no use to use temporal tables anymore. I think that's a good point. Okay. I would say that it's interesting because if you read through, this has happened. I would say that Azure's data warehouse documentation is a bit fuzzy in this too for their best practices, in the sense where sometimes they do refer to temporal tables as the practice that they want you to use. And so I would say that there's, I mean, it's good to, he's absolutely right on this. So thanks, Darren. Bashiru asks, sorry, I totally mispronounced your name. What are the best tools for data engineering? Hot potato, you're it, Matt.
This is a vast question, but I feel like if you're just starting out, so there's so many different tools for different use cases, but I feel like if you're just starting out in data engineering, then cloud data warehouse of some sort is a really good starting point. So something like Google BigQuery or Amazon Redshift or Snowflake, for example, or like Azure Data Warehouse. All of these are really great tools because they're highly scalable, like a traditional quote unquote big data tool, but they also use SQL semantics. And then at some point, you'll probably outgrow some of those tools, right? You'll need something beyond SQL, and then you can expand from there. I don't know. What are your thoughts?
It's like asking what's the best food,
right?
for? Like, what's the best vehicle? It's completely situation dependent. So it depends where you are, say, in the data engineering lifecycle. So we define this as being, getting data from source systems, ingesting data, storing data, processing it, and then serving data for end use cases, right? So there's best of breed tools all along the lifecycle here. And so I can't really pinpoint what the best tool is for a number of reasons. One, there is not a best tool for everything. And by or best tools, I would say there's best of breed tools, but here's the deal. Tools are changing so quickly right now, right? I mean, you can go look at Matt Turk's, he's got a fantastic slide at First Round Capital about the data tooling landscape. I think the last one was of 2020, but you can't read it. And I think it's the whole point. There's just so many tools on the spectrum. It's like it's hard to know where to start. I would say maybe best practices for evaluating tools would be pick tools that are modular, that you can bolt together. Whether those are managed services or open source, I think a lot of tools are starting to play nicely with each other, and either end of the spectrum, whether they're SaaS, managed, open source. Be prepared to swap tools out as new ones come along. We were talking earlier about Airflow and Dagster. I can make a strong argument that Dagster's, got a bright future ahead of it. And people who are using Airflow are probably going to be reconsidering at some point, because that's how tools work. There's no tool that has a long lifespan, really, except if you're talking about Bash. And then finally, I think there's some misnomers, right? Like, to learn data engineering, you need to learn Spark. To learn data engineering, you need to learn Hadoop and all these technologies. Data engineering is not a technology, right? Data engineering is a practice. And so you got to think of it the best way we think of this is in terms of life cycle, or the data engineering life cycle, right? There's the steps in there, and then picking the best tools within that life cycle. So I hope that helps. Kind of a roundabout answer, but it's a roundabout question. So
and let's add. I mean, what are some baselines? I mean, I think we believe that every data engineer should be pretty good at SQL, because it's just like a foundational tool, even if you're going to end up using Spark. Python is so common in data engineering. I mean, all of the big three orchestration systems, for example, are built on Python. PySpark is one of the major APIs for Spark, so get good at Python. I would probably say, learn some kind of orchestration, or at least learn what orchestration is, because regardless of the underlying tools you're using, orchestration is probably going to come up at some point. So,
Yeah, and I would also say too, I mean, we've been doing a lot of thinking about this, right? Like, what are the, where's data engineering going in terms of practices and tools? And whereas I think the conversation several years ago was, you could make a convincing argument that data engineering was very much a tooling conversation. The attention was on things like Spark, the whole Hadoop ecosystem, and so forth. I think as tooling becomes abstracted and as processes become simplified, i.e., other companies are doing the work for you behind the scenes, and you're not having to do so much of the first order work of just maintaining systems, data engineering is going to move very much up the food chain, where the concerns are going to be things like data operations, also known as data ops. So basically taking the best of DevOps and applying it to data as a product. Data management, this is a giant field that you're going to start seeing a lot of attention with data engineering, in particular things like data governance and all the subsets of data governance, data quality, lineage, metadata, and the list goes on and on and on and on. There's at least a dozen subfields in data governance alone. Other aspects of data management, data architecture, security, privacy and ethics, all these things are going to be interwoven and I think more first order concerns for data engineers. Additionally, the ability to write software. You're starting to see sort of fields, data catalog, it's another one, right? It's a piece of data management, data governance. You're going to start seeing a lot more. I think there's kind of two worlds. You're going to be engineering where it matters, and you're going to be using managed services and third-party tools for the rest. So data pipelining, moving data in and out of things, I think that's pretty much a solved problem. There's companies like Fivetran, Matillion, Meraxa, a ton of others out there. They do a fantastic job of moving data in. You got high touch census and move data out for reverse ETL. Like, pipelines to solve problems. So that where you're going to be coding, maybe it's in your transformations because that's specific logic. But like I said, the concerns are going to be changing a lot in terms of data engineering, which also influences the types of tools you're going to be using. So the type of tool, I thought we answered this question, but the types of tools you're going to be using, I think, are going to be more, kind of data management tools too. Things like data quality checks, data testing, data versioning, code versioning, all these things that will kind of maybe not first order concerns, first order problems. You know what I'm saying? So,
yeah. That was a very long-winded answer for both of us, but no, it was a big question. It was like fast.
I mean, you asked a question like, "What's the best tools?" I mean, we talk all day about this, right? Or write a whole book about it, which is kind of what we're doing. So Nick Acton asks, "What kinds of paradigms, papers, articles should one be looking for to transform data within an organization from relatively flat DB tables to a graph representation? Presumably strategies around ontology building."
Yeah, this is an interesting one. We've been hearing a lot lately about graph databases.
Yeah, I mean, I've only done a few ranking algorithms and graph algorithms, so I don't know that I'm the most qualified person to talk about, transforming data into something that's more suitable for graph representation. I mean, I don't know. Do you have experience with this in your math PhD? In terms of
not this specifically. Yeah, I mean, what do you think? Is Neo4j still the main game in town when it comes to graph databases?
Easily, yeah. They got like what 54% market share or some number in that area. Yeah. I can't really answer this question, I think, offhand, just because I don't have direct experience, enough to really qualify myself to say like, here's how you should flatten database tables. That said, Nick, hit me up with a message. I can put you in touch with people who can answer your question. So, yeah.
But I think right now, still, if you're trying to learn the domain, then per what you were saying about Neo4j, just kind of getting into the Neo4j ecosystem is probably a really good way to go. And just look at what other people are doing in that world.
Yeah, for sure. Hey, shout out to Andreas. What's up? Good to see you, man. Have to get you on the show soon. Andreas Kretz, great guy. What do we think of data mesh? I've been thinking a lot about data mesh. I think that it's, and I was talking to somebody about this the other day, kind of how it's, Andreas has an interesting question. We'll get to it in a second.
Okay.
But data mesh is an interesting one. I think, the notion is basically remove, the big idea behind data mesh is move away from monolithic centralized architectures, let teams decide what data to serve and how to serve it for the best use case. I mean, I think it encapsulates the bit. It's very much an application, I would say a derivative of domain-driven design, which was, it's been a software concept that's been around for ages, right? So each domain is in charge of, designing the services, executing the services for software. Now this is, translating into data. I was actually talking to somebody the other day about how this, there's maybe some controversy of how data mesh relates to Kimball. I'm not going to beat a dead horse. I think that, it doesn't, I don't think data mesh does away with any practices. I think what it does is it means you actually have multiple spots now where the data engineering lifecycle is sort of just a microcosm for each domain. At the end of the day, though, it's still, basically you're taking what you've done and just reducing it to a domain instead of having a centralized spot for everything. So that sort of describes what data mesh is. I think the thoughts behind it, I can see it being applied in certain circumstances. I still think that there's a lot of confusion as far as I can tell about how to make it work. It remains to be seen. I think it's too early to really say, to give a verdict on data mesh because I just don't see it being applied that much yet.
Yeah.
What are your thoughts?
So one thought I have is that even in more traditional data engineering, meaning not data mesh, we're seeing a similar paradigm emerging, and it goes back to what you were saying earlier about getting away from the monolith, right? Hadoop, traditional data warehousing that was very much monolith oriented, where there was kind of this underlying assumption that all your data was going to be stored in this huge system that would take care of all your needs. And now in modern data engineering, you're going to have data in some cloud data warehouse. you'll have a data lake. You probably use a bunch of different tools to access the data. That's already kind of wandering toward this data mesh paradigm, where I can see the full data mesh potentially being problematic. It's just the issue with like trying to query live transactional data with analytics queries, which that's been a problem for a long time. And so I think with data mesh, that's one thing you'd have to think about solving is like, if I have my my live data, say in DynamoDB, what's my layer going to look like to process that as analytics data efficiently? Once I kind of get that in place, then I can look at using tools like Presto that allow me to combine data from multiple sources into analytics queries.
Yeah. Yeah. I think, what I would hate to see is that people cargo cult data mesh too early, right? And then try and do it in their company, their startup or something. Like it seems like complexity, and the article does say this too, right? Like it's a practice that you should be doing when you're big enough to do it. So, but it's a good question. Stay tuned. I mean, I think we're going to be, talking a lot more about data mesh and, possibly doing some interviews with the data mesh crowd as well. So stay tuned on that. Raymond Tan has a follow-up question. Is data catalog and management a data engineer role or a data analyst role? I think it's LinkedIn user, says Raymond Tan, sits with the analyst domain. I'll push back on that. I think it's a data engineer. Okay, so I think there's a couple of threads to this question, right? So who maintains a data catalog?
Yeah.
And who populates the data catalog? So I don't know. What are your thoughts?
Yeah, so the way we view data engineering roles, and there are other opinions about this, but the maintaining the data catalog, and then I mean maintaining the system, making sure that it's accessible to users, making sure that it connects to different databases and has automatic scanning capabilities, that's probably a data engineer's responsibility, especially as we see data engineers moving away from really low-level coding more into data management type roles, where they're just responsible for having a knowledge of all the data and making sure that it gets delivered appropriately. At the same time, I would argue that the collaboration between analysts and data engineers is really, really critical. A lot of the boots on the ground work on data actually gets done by analysts. They're the people who know the data. They're the people who say, hey, this catalog entry is out of date. In fact, at a lot of organizations like Netflix, the catalog, it has a social layer where it's directly accessible to people who handle the data day to day and can make updates to, say, data descriptions and data problems just right in the catalog directly. Because that's kind of how I see it. Like the data engineers would keep that catalog running all the time. The analysts would actually be responsible for pointing out problems in the catalog and updating entries and things like this, because they actually understand the data really deeply. And that collaboration is what makes for an efficient data organization.
Right. Yeah. Whether you talk about GCP's data catalog or something like MetaHub, Data Hub or Metaphor. Sorry, I got the two mixed up. The open source, LinkedIn data catalog, right? Like that's just streams coming in and populating a data catalog. I would also say though, for a data analyst, it doesn't just stop with them. Data is a full contact sport, especially when you're asking for definitions, and so that analyst needs to be involved with various aspects of the business, getting definitions for stakeholders, making sure definitions are up to date, and communicating back. Okay, so this is the definition. Here's the data you need to do your job effectively. That's the other aspect of it too. So, in a perfect world, everybody's keeping the data catalog up to date. Maybe the data engineer, like you say, is maintaining it. The connections into it and the processing, but really the definitions, I don't think a data engineer has anything to do with that. That's at a minimum an analyst or a data scientist, and probably like everybody who touches data. So, because everybody has to have accountability at the end of the day, right? So you can't just leave it to a team. It has to be the company. So
yeah. And I think we've both seen cases where if the data engineers sort of act independently in a silo and just hand out data to other people without taking feedback, data scientists and data analysts don't get the data they need, and quality is not maintained because the engineering team isn't looking at the data enough to actually know ways in which it's broken and dirty.
Yeah. It was Sanjeev actually mentions Glue Catalog, which I think we want to touch on for a bit.
Yeah.
The thing I think Glue, maybe I need to check out more if they've done any changes to it. But
Yeah.
last time I checked, it was a catalog, but I don't think in the truest sense, where it was like, it contained actual definitions about data and access and all that kind of stuff. It was like a Hive meta store, but maybe it's changed. But it's worth looking into. Used products like Glue. If you're in AWS land. And back to the speaking of AWS too, Todd Hansman mentions Neptune. If you're in AWS, check out Neptune. Thanks guys. Question from Keaton. I think I pronounced your name right. Can you be more specific about SQL for data engineering? What is something in SQL we should be best or know in deep, except create, update, and delete? That's kind of like a rhyme. That's kind of cool.
It's cool. Yeah, I mean, okay, so here's, I'm not, so Joe and I are both pretty big advocates for SQL, but we're not saying that SQL is end all be all tool. But I think what I argue is that I see data engineers doing stuff in Spark and spending a lot of time coding things that are actually really simple in SQL. So here's a classic example. Often it's the job of data engineer to take raw JSON data coming out of some kind of database or an API and turn it into something useful. So they need to like extract these different fields out of that. And you can spend a lot of time trying to solve this problem in Spark, but many SQL dialects actually support accessing JSON data fields just directly. And so I would say, learn all these techniques for parsing, for dismantling data, for aggregation, learn how to use common table expressions to do more interesting transformations, and then also learn the limits of SQL. Understand like, oh, I can do this in SQL, but it's going to be really, really hard. Maybe this is a better problem for Spark and I should move over into that instead.
Mm-hmm. Yeah. I mean, there's I think a lot of other things too, like analytical functions, also known as window functions. Anything beyond CRUD operations, you're going to be doing something probably more advanced. Analytical functions, we use those all the time. Learn to use your statistical functions too, correlations, standard deviations, means, learn how to write a median. In SQL, actually, surprisingly, a lot of databases don't have a built-in median function, which also brings you to, well, okay, so then you might need to learn how to write a user-defined function, right? So, and stored procedures and all these other things. So yeah, there's a lot, in SQL, but I would also say, look at the magic methods at your particular data warehouse, and again, we're applying SQL to a data warehouse context, not a transactional database, right? But learn, maybe there's some, awesome commands, particular to that database, get to know those. But yeah, we teach SQL at the university, advanced analytics in SQL. So we have a lot of fun with this, almost too much fun. So
maybe so. Yeah, some might argue too much fun.
Yeah, our students might argue that. Sheesh asks, like Kaggle to practice data analysis or build ML deep learning models, is there something similar for data engineering?
We've been talking about this for a while, right? It's like there's still kind of a lack of data engineering educational resources. I mean, there are lots of articles and tutorials scattered across the web, but there's no, at this point, we're not finding a lot of really nice central repositories. I think there are some schools starting to come out though, right?
Yeah, Andreas has got one, right?
Yeah,
Shout out. He got his like one-on-one
awesome,
coaching. You should go sign up for that. That's awesome. And there's some other schools out there. I can't remember the names, which shows how like small, like new the field is of data engineering for teaching. There's, I would say though, here's something so there's a stat like 80, data scientists spend 80% of their time cleaning data, processing data, blah, 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 blah. 10% of their time, that's actually 20% if I give the number I gave, of doing actual data science work, right? So like model building, all this stuff. I could make an argument that, implicitly in some way, data scientists doing Kaggle and building these models have already been doing some data engineering work, because the processing and the cleaning of data, that really should be done by a data engineer. Actually, I just think that, it's only now getting recognized that was work that data engineers should have been probably doing all along. And I think in some companies they have, but, what's happened is companies will hire data scientists, kind of like us. And then we end up doing all the, building the pipelines and processing data and cleaning it, and not doing, the cool data science stuff that we, imagine that we would be doing. So, So I can make an argument that's kind of already been done in some ways in a roundabout way with Kaggle, but there's nothing explicit. There's not like a Kaggle for data engineering. I don't know. Maybe that's something that, anyone in this audience, if you want to collab on something like that, might be an interesting project. So shoot me a message, because I think something like that is needed. Just because the other question always comes up. Okay, so how do I build up my data engineering chops, right?
Yeah.
I mean, it's tricky. Again, shout out to Andreas. He's got some great materials, I think, on this in terms of structurally, learning tools and best practices around that. So that's cool to see. But yeah, we don't see a lot of people doing this, and we hope that changes, right? We'll be doing some stuff in that area. I know others are, but yeah, sorry, it's kind of a lame answer, but I mean, it is what it is. There's just not a lot out there. So
yeah. And I would add as well, like you were saying, doing data science really builds your data intuition. In other words, you understand what data looks like. And that's kind of like, that gets you partway to being a data engineer. And then the step beyond that is that to be a data engineer, you need to move beyond tools like Pandas, which are somewhat limited to scalability, get really good at SQL, and then maybe look at some other tools like Spark, and then get good at orchestration as well. How do I orchestrate all these transformations together? And so a lot of that is just spending time in these tools.
Yeah, shout out to Todd. He's got a good point here.
Yep, that's right.
Yeah, part of the issue is data science is much better defined than data engineering, which has a lot of overlap with other disciplines, including data science and analysis. So yeah, I totally agree. Which is interesting. Okay, so as an aside, I don't know what the hell data science means anymore.
Right.
So, it's one of those things. I scratch my head. I'm like, I thought I knew it, and then I don't. It's like Friends, and over time. I mean, data engineering. I mean, it's interesting because as we're writing this book, we had to define data engineering, and there isn't one. I mean, there's a lot actually. If you type in what is data engineering, I think the search result last time I checked yielded for an exact match like 370,000 unique results. It's a lot of different opinions. So I think the way we define it is, it's a practice at the end of the day to really dumb it down. You're taking raw data from source systems and you're making them useful for data analysts, data science downstream. And there's a lot that goes on in between there, but it's a field that has been around in some way, shape, or form forever. But yeah, I think to Todd's point, it's labeling as data engineering. It's a fairly recent term. It was either like ETL developer, software engineer, data scientist, actually.
Even architect. There's
architect. Yeah,
architect overlaps a bit.
Yeah, for sure. Sanji killing it with the questions. It's awesome. Yes. What about Spark plus SQL? We develop all of our data lake pipelines using PySpark plus Spark SQL and using Apache Airflow for scheduling the pipeline. Pipelines are running AWS EMR cluster and using Glue Catalog. Cool. Yeah. I mean, if it works for you, it's awesome.
It sounds like a good choice because in general, I recommend that people combine SQL with some other tool. Because again, a lot of things that are really hard to write by hand in Scala Spark are really easy in SQL. So pick the right tool for the job. It sounds like that's exactly what you're doing here.
Mm-hmm. Yeah. I mean, at the end of the day, I think he's the one, somebody asked about data engineering tools. And I think the whole crux of that is there's not a right, there's not an answer, let alone one answer. And I would say, if like I said, if it works for you, it works, right? So, that said, there's, it's interesting though, because, Spark and the data lake has been around for a while. Now you're even seeing that being abstracted. Like, shout out to a company called Upsolver. Like they've, come onto the scene very recently and have had a, data lake house as a service doing, so you can spin up a data lake without even knowing, Spark. So I just think, again, like a lot of these paradigms that you're seeing are just going to be abstracted away even further, because the pain point with the data lake is, well, now I got to learn, probably got to learn Spark or something, right? I'm not going to learn Pig these days. So
it's funny too, because we're still seeing so much activity in the data warehouse space, right? The cloud data warehouse space. One would almost think that that's a solved problem, but so many new and exciting tools come out every year. It seems like every month, right?
Oh yeah. I mean, with the latest one in the scene, for data warehousing is Firebolt. Right?
Exactly. Yeah.
right? Like that's getting a lot of attention now. I think we heard about that,
And then Apache
several
Druid
times. Druid, yeah,
has grown
managed.
to be a data warehouse. It didn't have joins before, so you couldn't really call it a data warehouse.
Yeah, right. You got ClickHouse, you got Kylan, there's a bunch, and it just seems like every day somebody's coming up with a better mousetrap in this area. So yeah, it's interesting because the whole tooling space, and we've been talking a lot about this. It's not consolidated. In fact, it's more fragmented. Every single year, there's new tools coming out. I think if there's one thing Snowflake did right, I mean, they built a great product. They went to market very well, and built a very valuable company. But with that also comes a lot of people coming after that market because there's a lot of value there. So I would say that it's the industry and tooling space is nowhere near consolidated. So, but if you have something that works, again, if you're using Spark and SQL and that works for you, then great. I would just also caution, like, tooling's changing, and there might be layers of abstraction that at some point maybe you need to review your architecture and simplify it even more. But that's up to you. If you guys like if you like pipeline, you can keep your pipeline. So
the other thing, you're a tireless advocate for just staying on top of the tooling, right? Data engineers need to be aware of what's going on, regardless of which stack they're using. They need to know what's out there, and I agree with that position. Every data engineer, to some extent, should also be a data architect, in the sense that they do need that awareness. And at some point, they may say, "Hey, we actually need some new tools in our stack here. Spark's working great, but let's look at what else is out there," without just chasing the latest technology. Choose what's appropriate and know what's going on in the field.
I'm sorry, talking with the mute on. Follow up. Yeah, no, I'm like lip syncing. Follow up to Sanjeev.
Yeah.
I mean, he has a data warehouse, big data, data lake, and nowadays people talk about lake house. And what is lake house? It's just basically, think of it like integrating your your data lake with something resembling, or literally as a data warehouse, right? So it's kind of best of both worlds, or worst of both worlds. So depending on where to look at it. So, but again, to me, it's more of a marketing term, because I mean, what it allows you to do is like decentralize, keep your storage from your compute, right? So if you want to keep your data in, an S3 bucket, for example, and just tie it into your data warehouse, you can do that, right? Or you could use again, something like AppSolver also solves this problem, just like Databricks does. What companies built a Druid warehouse, or maybe an article about that? Let me just share. I can just read. So imply.io, that's actually managed Druid. So they are the creators of Druid, and full disclosure, a partner of ours, just like AppSolver and a bunch of other companies, Snowflake. But let me just read some of the companies. You got Honeywell, Cisco, McAfee, I think Overstock, Unity, Adobe, AT&T, New York Stock Exchange, Atlassian, Reddit, VMware, and so forth, right? So a lot of companies have built, even on Imply, and let alone basic Druid. I don't know. You'd have to, look at the Druid community docs and see if they have any references for, users. But there's a lot. It's been around for a while. So
I mean, the truth is that part of the reason that Druid is so performant is that it uses a lot of different layers to manage batch and real-time data together. And for that reason, setting it up yourself can be very painful. And that's where, if you're just interested in trying it out, you probably want to try a managed solution like Imply. If you have a really big data engineering team that has the resources, then you can look at managing it yourself. But it seems like it's going to be a huge headache for most small teams.
Yeah, I mean, I would just say go with Imply. I mean, they do all the hard work for you, and I think they have like a community version too that's free, so you can just go try it out. But if the use case for that is if you're doing actual like real-time ingestion, and you need very fast response times in your queries, it's Druid all day. There's not even I would just go with that. So if you need like low latency queries, you can also use that. I would say it also then starts competing with other things, but the use case I would say is like just, real-time ingestion, real-time queries. That's, in large scale. That's where you want to use it. Yeah, good question, Tiago. Todd asks, any good feeds for keeping up with an ever-expanding tooling list? Oh my God.
I mean, maybe we need a Hacker News just for data engineering. I mean, I think we both skim Hacker News quite a bit, like
several times a day for me.
Several times a day, and just like pull out any data engineering articles. But it would be nice to have like a distilled Hacker News feed just for data engineering tool sets.
Yeah, I mean, it's to me, there's I follow a lot of, I mean, there isn't a good answer for this because I think there isn't a good feed, like, and it's lame, and Todd's going to hate this because I sense he's the kind of guy who likes simplicity in his life, and doesn't like the word Slack being thrown around too often. But I'm on a lot of Slack groups for different data tools and stuff like that. And Locally Optimistic, I think, is a great one for analytics tooling. The ML Ops community actually is a great place, I think, just for anything that it kind of intersects. I mean, it's mostly ML machine learning tooling, but there's also, a lot of great resources for stuff that I think overlaps with data engineering. I mean, if anyone in the audience has any good feeds, like, please throw these in the chat here. I mean, stumped us with this one. I can't really come up with a decent answer, but it has to exist, right?
Or someone needs to create it, right? Like so many things, if it doesn't exist, it really should. There's a vacuum.
So the assignments for the audience: come up with a Kaggle for data engineering. Come up with a good feed for a newsletter blog for all your distillations. Yeah. So I think it's directed at us, actually. So
Probably.
We actually have a newsletter coming out really soon. I think this is a good idea. Actually, a friend of mine, Sarah Catanzaro from Amplify, she does a really good job with her newsletter. Every week she has a newsletter that talks about kind of what's new in the mainly the kind of data tooling, machine learning space. That might be a good newsletter, actually. Amplify partners, sign up for the newsletter there. Life in the big city, Todd. Sorry. But we'll be coming up with a newsletter, I think, to just distill at least the ones that we're aware of. But again, it seems like every time you turn around, there's a new tool and a new idea, right? We talked about data mesh earlier. I mean, that's not necessarily a new idea. It's been around for a few years now, but I think there's ideas and tools that survive, and then there's ideas and tools that and most of them die off, right?
And some research, right? Yeah. I mean, I think we've seen that quite a few times where there's an old idea, maybe for a decade, then it dies out for a decade, and it comes back.
Let me see if I can reply to this. The newsletter is coming soon. Keaton asked, so if we have, how do I subscribe to the newsletter? Oh, wait. Well, you can subscribe right now if you go to ternarydata.com and just subscribe. Let me just type this real quick. Go to ternarydata.com to subscribe to the newsletter, and then I think we should be releasing that next week or two. So anyway, I think this is probably a good place to wrap up. We've been at it for a bit and probably either ranting or boring you to tears or not. So I think we'll be mixing in the regularly scheduled Monday morning data chats that we pre-record and release on YouTube and various podcasts. I think occasionally we'll be doing these live chats. It's really fun to hear from everybody out there. By the way, if you haven't, register for the Dedicated conference. It's going on tomorrow, the 18th, and Wednesday, the 19th. It's going to be awesome. Go to Dedicated conference or dedicated.com/conference. I think so. Thanks. Thanks, Raymond. That's good. Always good to see you. And obviously, please subscribe to our YouTube channel and the podcast where finer podcasts are available. It's on Apple Podcasts, Google Play, et cetera, and subscribe to our newsletter at ternary.com. So thanks, Rajiv, for the awesome questions. We'll see you next time. And to everybody in the audience, have a good one, and we'll talk to you later. Bye-bye.
Thanks, everyone. Thanks for participating. See you soon.
Bye. See you.